So good morning. We're going to continue with graphing linear equations. Another day, another dollar. Again, graphing linear equations is all about finding these ordered pairs. So the way we're going to do this again was we're going to find these three solutions that satisfy this equation. We're going to put this information in a table. We're going to plot those ordered pairs on our coordinate plane. Then we're going to graph the line that's going to represent the solution. So, excuse me. Our first decision is what we want to pick to make this a true statement. What we discovered, if it's solved for y, it's easy to find the solution by just picking values of x and then determining what y goes with that value that we picked for x. And we've discovered that we can pick, 0 is always a good number to try. It usually always works nicely. So if I pick 0 in for x, what this gives me then is, slide over a little bit, y is going to equal then this negative 1/3 times 0 plus 3. So I'm going to end up with negative 1/3 times 0 would be 0. I have 0 plus 3. So y is going to equal then 3. So this means that 0, 3 would be a solution. 0, 3 would be a solution. And I will go ahead and graph that. 0, 3 would be right there. Now, after this, since this is a fraction, remember fractions also have this concept of division, it's probably a good idea to pick a number that, since this 3 is the denominator, it's a good idea to pick a value for x that can be divided by 3. So I'm going to just pick a 3. So I'm going to have y equals then negative 1/3 times 3 and add 3. This 3 is going to go into 3 one time, so those divide out. I end up with a negative 1 plus 3, and then therefore I just have y equals 2. So if I pick x to be 3, the corresponding y value is going to be 2. So 3, 2 would be a solution to this equation. So if I put 3 in for x and a 2 in for y, that should be a true statement. Also, another number that we can choose that can be divided by 3 is also maybe just choose a negative 3. So I'm going to go a negative 1, 3, and I'm not just going to just put a negative 3 there this time. We haven't done that much. We also can pull in those negative numbers as well, because this can be pretty easy as well. We know that 3 divided by 3 is going to be 1. Let's change that to like a negative 1. And a negative 1 times a negative 1 is going to be a positive 1. So I'm going to have 1 plus 3, which in turn becomes a 4. So when I chose x to be a negative 3, the corresponding y value was a negative 4. So negative 3, positive 4 would be my other solution. So I'm going to graph these other points, 3, 2, 1, 2, 3, 1, 2, and the other ordered pair negative 3, 1, 2, 3, up 4. That would be the other solution. Let's see. Up 4 would be about there. So what I want to do now is sketch the solution, which is going to be the line itself. So we're going to draw a line through those 3 points, and it looks like those, again, I'm kind of sketching out a little bit. Those lines, those points look like they line up fairly decent. So this will be a sketch of a graph that represents the ordered pairs. So that line there would be considered our solution. So that's kind of our objective in these problems, is graphing this line. So right now we're picking up on a few things. To create a line we need just 2 points. But right now we've been just identifying 3 solutions to help us kind of make sure that we're in sync here. Some of the things we're picking up on is there's some patterns that sometimes will occur. You can almost see that these guys are changing by 3s. you know. And I can almost see that these guys, looks like they're changing by ones. There's some patterns there that we are starting to pick up on that may make this a little bit easier than doing this much work. And that's what it's all about in math sometimes, is if you start to pick up on these patterns can actually save you time over the long run. And that's what you're looking for sometimes, what we call efficiency. So once you start to pick up on some patterns, we want to use those to our advantage. So let's take a look at one more example here, I believe. Stay tuned.